All right, number four. Number four is starting to talk about electricity again. Which type of transformer would you expect to see at a generation plant of a utility? Step-down transformer, a step-up transformer, air-cooled transformer, low voltage transformer. Well, we can definitely take low voltage off the list. Low voltage is referring to a type of system that, like your alarm systems and your phone systems and things like that. That's a totally different animal. It's different from saying that the voltage is lower, right? You can have a lower voltage, but low voltage means something. So our big question is between A, B, and C, and really C we're not going to really think about either, although that could be a potential answer in the classic way of the exam. That's a reasonable answer, but it's not the most reasonable answer. So the question really is between A and B, is it a step-down transformer or a step-up transformer? This is kind of a terminology thing. It's just you have to get used to the way that they talk about it. The sort of key thing to take away here is that remember volts times amps equals watts. When we make the volts go way, way up, we actually make the amps go way, way down. So when you talk about high voltage systems, that means there's very, very low amps in that. There's this kind of odd relationship here, which is that the cross-sectional area of the wires carrying the power, carrying the total watts through that system, can be smaller if I have much higher voltages. If I have much lower voltages and therefore higher amps, the cross-sectional area of the wire goes up, is much larger. So you can imagine from a cost standpoint, if this thing is, say, 100 miles from the big city, and I would need to make the wires 5-6 times the cross-sectional area by keeping it at a low voltage, I'm just not going to do that if I'm a power company. I'm going to jump that voltage up as high as I possibly can in order to make those wires as cheap as reasonably possible, because there's a lot of them and they got to go a long way. So what we're going to do is we're going to step up transform. It's going to be B. There's going to be a transformer right there as the power comes out, as the watts come out of the utility. We're going to step it up to probably a few thousand. It might be 10,000, might be 18,000 volts. And it's going to then get sent in those high voltage lines, those big, big, big systems. It's going to get sent in the big distances that it needs to go. Then intriguingly, it'll step down when it gets sort of close to its end use. So it steps down to its distribution area. So then it might step down to a few thousand volts or something along those lines. And then as it gets distributed around through what we would think of as telephone poles or underground systems, then it'll get to the actual use point. So say, for example, a little house with the little transformer up on the pole out in back of the house. That's a transformer. That's where it's stepping down from the distribution level of power to the actual use level of power, to sort of the everyday use that we would normally find, either the 120, 240, that kind of range. So it steps up in order to do the big, long distances, and then it steps down to get distributed, and then it steps down again to get used. Now, in actuality, there might be 10 steps up and then 6 steps down. Every situation is going to be different. It depends on how close you are to the power generation. There's a whole series of different issues that are going to happen on here. But the gist of it is you're going to step up for the big distances. You're going to step down for distribution, and then you're going to step down again for actual use. So one little caveat to this that's probably worth remembering is, in this little sketch, I'm showing a little house with a little transformer out back. If you all go home tonight, go look out your apartment or out your outside of your house, you'll see that transformer. They're all right there. If you're doing a high rise, the same issues of higher voltage with lower cost because you want to keep the wires smaller are just going to be there for the high rise as well. I have a big distance to go up to, say, a 30th floor or 50th floor of a building. So on bigger buildings, instead of having those transformers outside, I may well have them actually stationed at different points through the building, inside the building, which can cause some interesting issues, right? I now have very high voltages moving through the building. So there's a lot of specialty safety stuff that has to happen, but that's worth doing because it's so much different in cost. You would actually have to have very, very large, like, chunks of copper in order to get the total amount of power needed for those elements. And that's just not reasonable. You want to do it through sort of more simple wires if you can. They're still going to be big wires, but you'd want to do it through wires as much as possible. So they'll run very high voltages and then have transformers at multiple stations throughout a building. So fairly simple and straightforward, but that's like when you hear high voltage power lines, they're much higher up in the air, they're far away from people, they're very dangerous. And then when you get to distribution, you drop it down. When we get to use, you drop it down again.
Today's A.R.E. Live episode is an extension of our online A.R.E. curriculum that you can find on blackspectacles.com, the home of online learning for architecture and design. If you need to prepare for the A.R.E., which I assume many of you guys do, and if you're looking for a good way to study for the exam that's more flexible and easier to digest than the traditional exam prep materials, then head over to blackspectacles.com to try out any of our free A.R.E. video tutorials that are taught by tonight's presenter, Mike Newman. As an attendee, and as you can see here on the screen here, we have a couple of notes or information for today's episode. Anyone who is attending today's session, you're eligible to use this coupon code worth 15% off the first charge on your individual membership. If you're one of those folks who would like for your firm to purchase Black Spectacles Access for you and your colleagues, just visit blackspectacles.com/business, which is this fourth link here, and we'll send all the information for your firm to get set up. And also from now until the 15th of next month, firm memberships are 15% off if you mention this episode when you submit your form through blackspectacles.com/business. Also on this, you'll see that our next webinar will be on May 27th with Mike at 6 o'clock. So if you'd like to register for it, here's the registration link. We're still firming up the details and the actual topic. So if you have any suggestions and would like Mike to cover a specific topic or would like us to interview someone in particular about a specific topic, please let us know.